Let's consider two planes, pi1 and pi2, with the equations as r dot vector n1 equals to d1 and r dot n2 equals to d2. The two planes will be parallel, pi1 and pi2 will be parallel if vector n1 is equals to a constant times vector n2. But if this is not a situation, then the two planes must intersect, and the point of intersection is always a unique line. If we find a vector b which is a cross product of vector n1 and n2, will be a vector which is normal to each of the plane. This vector will always be the vector which is along that particular line where these two planes are intersecting. And if the planes equation are such that vector n1 is a1i plus b1j plus c1k, and vector n2 is such that it is a2i plus b2j plus c2k. So vector b can easily be known. For example, suppose we have two vectors with Cartesian equation as x minus y plus 2z equals to 5. This is the equation of first plane, while the equation of second plane is, suppose 2x plus y minus 3z equals to 10. Now if we need to find the normal vector along the first plane, it should be I minus j plus k, which are respective, plus 2k, which are respective coefficients of x, y, and z in equation 1. Similarly, the normal vector to plane 2 is 2i plus j minus 3k. So the equation of a vector which is normal to each of the vector is the cross product of these two vectors, which will be expansion of the determinant whose first row is ijk and second row is 1 minus 1 2, which are the coefficients of x y z in the equation of plane 1, and third row is 2 1 minus 3, which are respectively the coefficients of x y z in plane 2. This will be equal to 3 minus 2i minus minus 3 minus 4j plus 1 plus 2k, or this vector is I plus 7j plus 3k. Now if we wish to find the equation of that line which is at the intersection of these two planes, we must arbitrarily set one of the variable equal to a constant value. So let's say z is equals to 0. So it gives me x minus y equals to 5, while 2x plus y equals to 10. On solving further, we will get that x is equals to 5, so the value of y is 0. So one of the point that lies on that line will be 5, 0, and 0. So now we will have to find the equation of a line which contains 0.500, and the vector along that line or parallel to that line is vector b. So the required equation of such a line is that vector r equals to 5i plus 0j plus 0k plus lambda times vector b, which is I plus 7j plus 3k. So in the vector form, this equation is equals to 5 plus lambda I plus 7 lambda j plus 3 lambda k. We can write the Cartesian equation of this line either through this vector or maybe directly. So the Cartesian equation of this line is x equals to 5 plus 7 lambda, y equals to 7 lambda. I'm sorry, the equation will be 5 plus lambda and y equals to 7 plus 7 lambda and z equals to 3 lambda.